Hello, everybody, and welcome to this webinar. My name is Ala Al-Bahrani. I am a regional cybersecurity leader at GE Saudi Arabia. I'll be walking you through this webinar today, and we'll be talking about how to protect ourselves against common web application vulnerabilities today. A little brief about myself. As I mentioned, I work as a regional cybersecurity leader at GE Saudi Arabia, where I'm responsible for protecting GE and its customers from various threats and risks in their systems and environments. My work experience goes back all the way to 2004, so that's almost 14 years of experience where I've worked different roles in information technology as well as information security. And I started focusing on information security about 7 years ago. And throughout that, web application security was one of my main focuses or one of my main concerns. And that's why I'm glad to have you here today with me to talk more about this topic or about this subject. So let's move ahead and see what we have as for our agenda today. We'll be talking a bit more about the environment of a web application, what it is, how it operates, and what are the different components associated with it. And we'll see that this is going to be important for us to understand in order to protect against web vulnerability applications or web application vulnerabilities. We'll then move towards talking more about the top attacks that we might face when we have web applications in our environments. We'll talk about some of the vulnerabilities associated with them in a bit more details to understand how hackers or attackers actually perform these malicious acts. And then eventually we'll talk about how to protect ourselves against them and what is the best course of action to take when we want to achieve a good or a base security level. We'll end our session with some questions and answers, hopefully from your side, and let's dive in directly. So web applications are basically an application that sits on a web server, and it's called a web application because it uses the internet or it uses the web or a network to connect between client and server. Most applications, or the majority of them, they have a database backend associated with it, so that's where the data might come in or be processed. And it can be accessed by many platforms. So it could be a web browser from a computer machine or a laptop. It could be a web browser from a mobile device or a tablet. Or it could be even a set of applications in these mobile devices. So I could have a mobile app sitting in my hand, connecting to a web application on the web as well to communicate. And that's the platform which is mostly used nowadays. Now, this plays very well with organizations because it doesn't require much of installation when it comes to distributing your application across a network. The maintenance of such infrastructure would be much more easier to maintain as well. Unfortunately, since it's connected to the web, just like everything else, it is vulnerable to attacks, and we need to protect ourselves against them. So let's see exactly how a web application is laid out through this design in front of us here. So I have my client side of things, which could be a computer or a laptop or a desktop machine. It could be a mobile device or a tablet or a phablet as well, and it uses the network of the internet or any local network as well to connect to a web server, basically. Now, on top of that web server stack sits my web application, and it interacts with the client based on that communication. Now, the web application itself, as I've mentioned earlier, could have a connection towards a database for its backend. That's where the data will be stored, modified, and manipulated. And the web application might also connect to some third-party components as well. The third-party components could be libraries, for example. We'll see this also in the coming minutes. Or it could be direct connections to third-party web applications as well. And this is a dependency that many web applications these days depend on. And you will see them connecting to other web applications in order to obtain certain services and so on. The services could be as simple as storage. So that the web application might use a cloud-based storage in order to save its files or to manipulate the storage associated with it. And this layout shows to us one critical thing. In order to protect a web application from its vulnerabilities, we need to keep in mind, or we need to consider every component that we see here, and we need to provide the protection for each and every part of this slide. So more about this to come later on. We'll talk about protection. But let's move on and talk about the vulnerabilities associated with them. Now, there are many vulnerabilities associated with web applications, given the fact that there are many components associated with it. There are many ways to connect towards a web application, and there are many parts associated with the web server and the platform itself. But just to summarize and to see our top vulnerabilities or top attacks, we can see from this chart that cross-site scripting and SQL injection compromise almost the majority of the attacks. And this is what we will be talking about also in this webinar itself. So again, these figures, they change every once in a while. They fluctuate a bit, but the trend, let's say, or the rhythm of these percentages, they stay the same. Cross-site scripting being the largest chunk of the chart, and SQL injection following up closely, as well as other type of attacks such as file inclusions and directory traversals and so on. Now, just to give you a figure of how large a problem vulnerable web applications are, I'll talk a little bit more about content management systems and the vulnerabilities associated with them. Now, a content management system is basically a web application which allows a web publisher or a company or an organization to publish its content online without going through the hassle of creating those web pages from scratch. The most famous content management system out there is by far WordPress, and others are also there. Some of them are freely available, some of them are commercially sold to organizations and companies, but they all carry the same concept, in which I don't want to bother myself with the details or the workings of a web application or the internet itself. I just have content that I want to publish. So WordPress plays a very good job at doing this, and that's the reason why it takes over the majority of the market share of CMS systems. So the statistics that I found recently was around 75 million websites are running WordPress nowadays on the internet, and this only shows you that if there was a vulnerability associated with a content management system such as WordPress, then that vulnerability will distribute across all of the websites running that CMS system. And we'll see this very clear in this chart as well. The amount of vulnerabilities associated gives our web applications the vulnerable state that they are in. And if we look at the right hand side of the chart itself, again we will see that cross-site scripting represents a majority of that chart, and followed by SQL injection in black also plays a major role, or a major chunk of that chart. Now on the left hand side, we'll see that WordPress, or the vulnerabilities available in WordPress, are divided across various components. So in blue, we'll see that the vulnerabilities discovered or published affecting the core engine of WordPress are something around 20% of the chart. But then again, when we look at the other half of it, which is more than 50% even of those vulnerabilities, are coming in from the plugins that developers write up, or companies that write up in order to work with WordPress. So having a vulnerability associated with a plugin that I'm using in my content management system will also inherit the vulnerability to my system as well. And this also opens up a much larger door when it comes to attacks and protecting against them. And likewise, themes also have their own percentage when it comes to vulnerabilities and so on. So just to recap on things, or the reason why I'm showing you this is, when we want to protect ourselves against the vulnerabilities in web applications, I need to consider all the components like I've mentioned earlier through my talk. So in this scenario here, when I'm talking about WordPress and specifics, I need to countermeasure whatever vulnerability is associated with the core engine of WordPress, as well as anything that comes out of the plugins in terms of vulnerabilities or the themes that I'm using in my systems as well. So enough about CMS, or content management systems, and how or an example of web applications. Let's move on towards talking more about the common vulnerabilities and how to protect against them. Now in this webinar, I'll be showcasing to you 4 different types of vulnerabilities. As I mentioned earlier, cross-site scripting was one of the most common spread of vulnerabilities, so we'll be definitely talking about that. Then we'll talk also about SQL injection and the different types of attacks that can be carried out. We'll talk more about parameter tampering. That's a nice type of attack, a simple type of attack that can be carried out, which can prove also highly risky to your organization. And then we'll talk also about command injection or file injection attacks as well. So let's move on into the first type of vulnerability, which is the parameter tampering attack. Now, parameter tampering attack is basically manipulating the values of the parameters that you pass into your web application from your clients. Now, parameters can be changed or modified, or even given out into the application in different types of inputs. One of the most famous types, or the easiest type that developers like to use, is passing those parameter values through URLs. And you'll see here that I have a sample written up to show that the value of profile is equal to 741 and debit equals 1000. And what we're trying to illustrate here from this URL is that we're trying to debit an account number of 741 with the value of 1000. Now, an attacker or an hacker can come in and deliberately change that value as easy as it is in that URL and hit the enter key to submit that value. And that will request the web application to act differently. So instead of debiting the value to 1000, it will actually debit it to 2000. Now, obviously, the example that we see here when we're talking about a banking transaction is not, let's say, an example that we might find on the web at this time. But you can measure this with other actions from other type of systems when we're talking about downloading certain files, for example, or when we're trying to traverse a certain directory in order to retrieve the rest of the files, or when it comes to sometimes search queries and when we're trying to manipulate the query that we pass to the search engine itself. Now we'll see that parameter tampering or URL parameter tampering is something that we might use as well when we're talking about SQL injection, and we'll see that later on here again. Now, parameters are also passed to a web application through hidden fields in forms. And an example what I have here, or the example that I have here, is that when you're trying to purchase a certain item from an e-commerce website, there might be a hidden field in that web page to indicate the ID of that item or the number of that item, as well as the value associated with it. And if the web application was vulnerable to this type of attack, then the hacker might come in here and change the value of that item in order to place an order with a much lower cost, for example. Or it could be as simple as changing the shipping address of a certain order as well. So anyways, parameter tampering could happen through URLs, or it could happen through hidden fields as well. Now, if you might ask the question of how would the attacker manipulate, or let's say submit the change that you did in the hidden fields. I mean, in the URL tampering, I've mentioned that you would change the value and click on enter, and then that's it. You would initiate the request with the web application to take action. But in hidden fields, it's equally simple. The attacker might use the developer tools in the web browser in order to submit the values of forms to bypass the controls associated with it. And this is something that you might see as well in different types of attacks also, such as bypassing JavaScript controls or form limitations and so on. So a simple command in the console of the developer tools in the web browser would allow the attacker to submit whatever values that he changed or whatever parameters that he changed in those hidden fields in the page itself or in the web application itself. Now, moving on to the second type of attack, which is injection attacks. Now, in injection attacks, what happens is that the attacker would embed or inject malicious code into the web application in order for it to perform other actions or unintended actions or malicious actions against the user. Now, the injection scenario that will happen here will all depend on bad coding practice in the web application itself. And that bad coding practice is what allows the hacker to make use of these attacks. And an example that we might see right here is we might have in one of the pages of the web application an include directive which actually gets the name of the page and displays it for the user directly. And we'll see this in many web applications where they try to follow a certain template to be common across all the pages, or a certain theme that they want to follow. So instead of rewriting everything from scratch in every page, they would have a single index page that will take in certain parameters and show or display the page accordingly. So the example here we have is that the index page will actually look up a members page, include it, and then return it back to the user in order to showcase it or display it to them. And the code associated with it could be a simple directive such as include the page name that we see in the example here. Now, if no validation is done across this input or this include, then an attacker might come in and submit a change in that value. So instead of having members.php like we see here, they might include their own code or their own file or their own command written in that file itself, and displaying it to the users. Now, you might think about how to use, or how the attacker would actually utilize this, because if he or if she adds that, if it tries to activate that URL, then the second example that we see here, then the page will display on his own computer and his own machine, which will not be of much benefit to him. So instead, he will forward that URL to a certain victim and have the victim machine or the client machine clicking on that link or activating that link. And we will see this also in phishing activities or phishing campaigns that you might see. That's one example of seeing this. This is relatively close to the concept of cross-site scripting, but I'll just keep it as it is here, because in injection attacks, I will be more concerned about activating or running commands on the web server or the web application. The example that I'll show you here now indicates this clearly. So here I have a partial script from a web page in a web application that actually pings a certain host and returns that ping value back to the web browser. Now, this is something that you might see in many network tools present online these days. We use these tools in order to diagnose our network connectivity, to make sure that the machine or the host is pingable from outside of our network, and so on and so forth. So in this example, the host machine is google.com, and the web server just pinged that host and immediately returned the value or the result of that ping on the web browser itself. Now, the vulnerability might come in without any input validation again here, and a user or a hacker might append to that ping command another command to run on the operating system, because the web code itself or the web script itself here is a simple execute command without any input sanitation. I could come in and inject something similar to this. Now, if I add the semicolon and whatever command, and I just execute it, then that will be considered as two commands on the command prompt. And this will allow the attacker to inject any command that he wants, and the result will be returned back here. Now, some of you might ask the question of how would an attacker know how the code is written and the way to manipulate it or the way to actually exploit it. Now, there are two answers to this. One answer is that if the web application is an open source web application, or it's a web application that can be obtained from the same source as the organization is, then that might give the attacker the ability to review the code associated with it and find any vulnerability in such. This will take me back to the example, or back to the slide where we talked about WordPress. Now, WordPress is a freely available content management system. And so just like an organization that might download that CMS in order to run its web application on it, an attacker or a hacker might also download the same thing and look out through the code in order to find any vulnerability to exploit. Now, that's one way of it. The second would be that these vulnerabilities would be published later on. The reason why they would be published is because they want people to patch against them. They want their security levels to rise by closing those vulnerabilities to deny any exploitation of them in the future. So if a vulnerability was published, an attacker might take use of that time before patching in order to exploit it. So if I have an old version of a web application running in my system, now that old version might have vulnerabilities which were not patched, and this will also introduce another issue to me in which attackers might exploit and use against me. So the code could be obtained depending on the type of web application it is. And the second method is analysis. Attackers, they try to analyze how the code is written. They try to guess how the code is written based on the results and the replies that they get back from the web application. So they'll be going through a lot of trial and error in order to exactly understand how that web application is operating, and then they would immediately exploit it when they find something with it. So enough with injection attacks. Let's jump in directly to cross-site scripting, which is a little bit more interesting, and it's a little bit more trendy and available, used a lot these days. Now, cross-site scripting is basically running a script on a victim website to be executed on a victim machine or a victim client. So the illustration that we have here showcases a vulnerability in a certain website where a hacker comes in, injects a malicious script into that website, and that script will be executed, or it will be run whenever a victim accesses that legitimate website. And then depending on the script activity itself, it might perform an action on behalf of the hacker, or it might even send back information or retrieve data or steal data from the victim machine or the client machine back to the hacker. Now, why this attack is successful is because victims here are not connecting to malicious websites. Victims are actually connecting to legitimate sites that they trust. They are connecting to sites that they are used to connecting to and dealing with and exchanging information, and the trust level is high between the victim and the website. But and this plays to the favor of the hacker here. So even if the website displays some weird pop-up, for example, or it acts in an abnormal way, for example, because of that trust level, the victim will fall prone to that vulnerability very easily. Now, cross-site scripting comes in two flavors. It could be something which is stored, or it could be something reflected. Stored meaning that script, or the malicious script that the hacker embeds, will be stored on the website or through its database backend, and we'll see examples of this in the coming slides. And the second is reflected, where the script is executed on the fly. So nothing is actually stored on the website, but because of the vulnerability there, that script will actually execute for the victim without having anything stored on the website itself. So let's see a couple of examples about this. Here I have cross-site scripting and attributes of web pages. Now again, these attributes can be modified by a certain form, for example, in a web page, and then that form will be called out by the client machine or a victim machine and to be run. So one of the examples here in order to do this is to duplicate or replicate or mirror a certain web page from a web application, and change those values there, and then show it to the victim machine in order for them to run it as well. Now, scripting could also be encoded in order to avoid the detection, and this is what we have in these remaining two examples. One is encoded URI schemes, and the other is having the code itself encoded, so it wouldn't be identified as easy as it was in plain text. And the reason why attackers perform this is to avoid detection and to have their code also ununderstandable in such a way that a non-aware user will not be able to tell the difference between it. So here, the base64 encoding that we have is a simple script tag that will raise an alert. Now, the scripting here is where the risk comes in. It could be the matter of changing values on the machine itself, retrieving cookies, for example, initiating requests from that victim machine. So if a banking application was vulnerable here, an attacker might use that cross-site scripting attack in order to initiate a banking transaction from the legitimate client's machine. And the transaction here could be anything, such as fund transfer or password change or whatever it is. Now, another example that we might have for cross-site scripting is the displaying of information on websites or web pages. So here I have an example that displays an employee ID. That ID is gotten from the URL parameter or from the request URL parameter, like we see here. And because of no input sanitation or validation done, the user might input the script or might use that URL parameter in order to input the script to run on the victim machine. And once he sends out that URL to the victim, that URL will actually execute that script. And this is one way of, or one example of a reflected cross-site scripting attack. Now, the right-hand side, you will see the code that actually retrieves data from the database, and based on that data retrieved, it will be displayed on the web page. Now, the data here will also can be also contaminated by a certain script, and this is where the page will actually deliver that script, for example. Now, this is an example of a stored cross-site scripting attack. We will see this in examples such as comment fields in blog posts, for example, or guest book signatures in web pages or websites as well. So a user might come in, and instead of inputting his comment or feedback about a certain post or about a certain website, he will use that input field in order to input any script and store it in that database. So whenever a user accesses that page to see the previous comments, for example, that script will actually activate. Another example for cross-site scripting is the error page example. Now here, the script that you find, or sorry, the code that you will see in front of you is basically the 404 error page, for example, that we see in a website. The page does not exist, so there's a specialized or a custom written web page that tells us that this page does not exist, and it actually gets the input from the URL or the request URL of the page name, and it says that the page is not found. So here the example could be testsite.test/file which does not exist, and then the result or the output would be not found/file which not exists. Now an attacker might abuse this and provide a URL such as the one written here with an alert statement or a script to alert for testing purposes, and then that script will actually be embedded in the 404 page, and then the client will actually have that script initiated or let's say executed on their machine also. So again, these type of scripts, they play very effective because the URLs, or for example, or the websites that I'm trying to inject those code with and send it back to the client machines are trusted websites or trusted web applications. So the users, once they look at the URL, once they look at the domain associated in that URL, they will not hesitate in clicking on that link, opposed to sending out a malicious website looking link where users might be educated enough to avoid clicking that link itself. So this is why cross-site scripting is a very serious matter, or a very serious attack that we need to look out for. So moving on to the last type of attack, which is SQL injection. Now, SQL injection is basically the execution of SQL code or SQL statements into a web application, and this allows the attacker to either read sensitive data from the database, modify that data, or even execute certain commands with regards to the DBMS or even the database server which is hosting that database itself. And this is not an issue associated with the DBMS or the database management system or the database server itself. It's an issue associated with the web application, and again, it happens because of bad coding practice as well. This can be avoided by fixing your web application code. So let's see a couple of examples about SQL injection and how serious the matter is. The first example here is called the tautology example, in which we try to bypass a certain logical condition by offering a value which is always true in my SQL statement. So here, as an example, I have a statement to query for a certain user ID in order to verify that login username and password. The statement would be select star from users, where user ID is equal to this value. Now here, if a user comes in and inputs any random value, and then he adds the part where it says or 1 equals 1, for example. Now 1 equals 1 as a condition or as a logical condition is always true. And this could be anything. It could be 2 equals 2, for example, or A equals A, whatever true condition that the attacker decides to provide here will actually show true to the SQL statement, and it will bypass that condition there. Now, another example that will also be useful in these type of scenarios is called the batch SQL statements example. Now here, what the user does, or what the user decides to do, or the attacker decides to do with this query, is that he adds an extra statement, or he batches another SQL statement into the original statement. So my original SQL was select star from users. and he added a semicolon and then another SQL statement. Now, an example that we see for us here is drop table suppliers, for example. Now, this statement could be anything. It could be another select statement. It could be an insert. It could be an update. It could be a delete, and then the list goes on. But the vulnerability here allows the attacker to execute another SQL statement, which is not intended to be actually run on that database itself. Another example for SQL injection is the union attack, or the union example. Now, in union, what happens in SQL statements is that I want to concatenate the results that I obtain from a certain select statement with the results that I gather from another select statement. So it's like querying two tables at the same time and concatenating those results, or querying a table based on a certain condition and then adding or concatenating with the same table from on a different condition, and so on. So here, the example I have in a search bar in a web application, and the search bar is supposed to search for certain books where the title of that book is something similar to so and so. So the statement is select star from authors where the title is equal to this and that. In the attack, the attacker might come in and adds any condition to close that previous statement, and then he adds union select 1 or 2 or 3, depending on the number of columns I have here, from a certain table, and then the dash that I see in the end here, this is just to comment out any remaining part of that statement itself. So here also the union example, this is just an example of obtaining the table layout or table structures from your information schema. This could be anything as well, and most of the time this type of attack is carried out in a search bar or in a search field, because the results that come in most of the time are multiple columns, which allows the attacker to gather more information about that data in the database itself. So this type of attack is used most of the time to extract information rather than actually carrying out an extra action, like we saw previously where there was a table dropped or something was deleted or something was inserted as well. Now, SQL injection is a serious issue as well, because we have so many tools out there that will automate SQL injection attacks. So even if we have a hacker who is not proficient, or he doesn't understand the ins and outs of SQL injection that much, there are tools out there that will help him in carrying out his SQL injection attacks in a much more complicated and a much more complex way than what we saw in the previous examples there. So this only shows us that we need to have a very high level of protection when it comes to SQL injection attacks. The second thing I wanted to mention is the examples that I showed you just now. They were depending on the search bar input, and as well as the login field input that we have in our web application. But SQL injection can handle or can work with any type of input that you have in your web application. So, for example, the newsletter registration field can also be used to do so. The input fields or the hidden input fields as well in your web application can also be used to do that. The parameters that I pass in my URL can also be used to perform SQL injection attacks. So any type of input that I have for my application can be used to actually attack it or perform SQL injection against it. So how do we protect our web application after looking at those type of vulnerabilities and seeing the different types of attacks to it? The approach to protecting our web application is something similar to the approach that we would follow in any security countermeasure or in any type of device or component of my organization that I want to protect? The answer to this would be to provide defense in depth, or to provide a layered approach in order to protect against any attack or risk associated with it. What I mean by a layered attack is that if you remember the components that we talked about earlier when we described how a web application would work, in order to protect that web application which sits on the top of those layers, I need to make sure that I am protecting each and every layer of my stack. So I will start off with my physical security, for example. I need to make sure that my servers are laid out in such a secure physical environment. I need to provide security on my network layer as well. My access to the network, for example, has to be protected. My, for example, Wi-Fi access has also to be protected, and so on. I need to provide protection on the operating system level. It's pointless to have protection running in other ways and my operating system being vulnerable to exploitation as well. My web server, if it was Apache, IIS, Tomcat, or whatever it is, I need to make sure that I am following the best security practices and security hardening the tips in order to make sure that my web server is running as secure as possible. My database backend has also to be protected. My third-party components, and this is a very important layer or a very important part when it comes to protecting against web vulnerabilities, is because I might be hacked, or my web application might be hacked because of a third-party connection. Now, a third-party connection could be a simple library or a framework that I use in my code, and because of a vulnerability associated with it, I might be vulnerable as well. Or it could be because of a connection that I provide in order to have, let's say, integration with other web applications. And because of that integration, my web application might be hacked. Once I do all of that, I come into the last layer, which is protecting the web application itself by looking at the code itself. Now, web application protection has to have proper coding. It has to have best practices when it comes to secure coding, and it has to have input validation when it comes to it. So these are the things that I need to focus on and consider when I'm writing a code for my web application. I need to test it. I need to make sure that every component of that code does not fall vulnerable to SQL injection. And then I need to make sure that I'm performing input validation for every type of input that I have in my web application. All of this, or all of this layered type of defense, will help me in protecting my web application against these common vulnerabilities and the other vulnerabilities that we might not have discussed in these slides or in the webinar here. One more thing I can do in order to provide an extra layer of protection against web application vulnerabilities is by introducing an appliance called a web application firewall, or a WAF appliance. Now, this could be a physical device, or it could be a virtual soft device embedded in front of my web server. This device will basically scan all the inputs that might come in order to protect against them. The last thing I have here is honeypots, and honeypots are systems that can be used in order to lure attacks and in order to protect the system by, let's say, diverting the attacks from the hackers. I hope you enjoyed the session today, and I look forward to hearing your questions and discussing any further topics. Thank you very much.